So before this video starts, I'd like to state that the intended target audiences are going to be students in Precalculus, students who are preparing for Precalculus, and students who are using this to prepare for calculus. So in the last video, we talked about the 6 trigonometric ratios, and they are known as, you got sine, cosine, tangent, cotangent, cosecant, and secant. And by the way, the abbreviations are as follows. You got sine, abbreviation is SIN, cosine's abbreviation is COS, tan's abbreviation is TAN, cosecant's abbreviation is CSC, secant's abbreviation is SEC, and then cotangent's abbreviation is COT, or COT for short, basically. So we mainly talked about some ratios here, and we did gain an introduction to some of the identities here, but now's not the time that we mention trig identities, because we have to graph functions too. So let's use our example of a right triangle and see how we can find missing sides, and eventually we're going to come to the point where we're also going to find missing angles as well. Again, this is to the best of my ability, so assume that all 3 of these lines are straight. So let's say you have an angle here. You need an angle here in order to use any trig ratio here. Then let's say this is 45 degrees. Well, this actually makes a 45, 45, 90 triangle. So let's actually do something like, let's say, something random, 36 degrees. Right now we're doing stuff in degrees. We're not doing measurements in radians because radians is for another part. And then let's say you have the side, one of the sides given. So you have, let's say you got this as 8. Now you want to completely solve the right triangle. Now I know this is a lot being thrown at you, but you can take this challenging problem and break it into bits as well. So you can solve for one side, and then you can solve for one angle, and then solve the other side. So there are 2 things you can do here. You can solve the missing angle because we have a right angle and 36 degrees. So you gotta subtract this from 180 here. And I think I should also mention this. This should be angle X, then this should be angle Y, and this should be angle Z here. So we're going to solve this Y. Y is going to be equivalent to, you get 180, because that is going to be the sum of all the angles in a right triangle, or any triangle in particular. So that's going to be 90 plus 36. And if you use a calculator, or if you're like me and don't need a calculator for something like this, you should be able to get, you get 180 minus 90 is going to be 90, and 90 plus 36 is going to be 126. And now you gotta keep in mind that you can also add the unit as well. In fact, some teachers may take away points if you forget to add the degree symbol. So as you see, 126 is going to be the angle right here. And now we can solve for the rest of the sides. So unfortunately, we can't use Pythagorean theorem as of course we have two unknown sides. But we can use our trigonometric ratios here. So let's use sine here. And as a recap, you can use the acronym. You got SO, which is short for sine opposite hypotenuse. Then you got CA, which is CAH, cosine adjacent hypotenuse. And then you got TOA, tangent opposite adjacent. So we can actually use like a 36 degrees and 8 as part of our calculation here. So we're going to go ahead and do sine of 36 degrees and that's actually going to be equivalent to, you got opposite over hypotenuse. Opposite is the side opposite to the given angle. So in that case, we're going to have 8, and that's going to be divided by, let's say you have an unknown here. But let's call this z, because the side z is usually opposite to the angle z, as well as this should be y and h should be x. So now what do we do? So we can use our algebra skills and solve for z. So we can basically multiply z on both sides to balance out the equation. And then we can divide both sides by, you got yourself sine of 36 degrees. So sine of 36 degrees goes away on both sides. Divided by sine of 36 degrees. Now, this will be the exact answer, 8 divided by sine of 36 degrees. But let's say you want to approximate the answer. In this case, you need a calculator here. Now, the main reason is that 36 degrees is an angle that's not on the unit circle. And the unit circle is what we're going to use later on once we familiarize ourselves with angles and how to find the missing angles as well. So we got z equals, let's say you got 8 divided by sine of 36. So I'm going to use my calculator here. So it's going to be 8 divided by sine 36 is going to be 13.61. And now we can use the 13.61 as part of the hypotenuse. And that's supposed to be decimal points. Now, what we could do is we can do 3 things. We can use cosine if we have 36 degrees here, because adjacent over hypotenuse, and then you can also use tangent. You could also use tangent and sine with this 126 degrees as well. So I actually misinterpreted this, and I said this was minus 126. So that's actually going to be, so my mistake, this was actually supposed to be So yeah, this was actually my mistake. This is supposed to be 180 minus 126. So this is 180 minus 126, which is going to be 54. It's actually going to be 54 degrees because we have a right angle and all two of these angles have to be acute otherwise. So that's actually going to be 54 degrees. And now we want to solve for the remaining side here. Now it's best not to use our side that we just got because it isn't really accurate unless you use the 8 divided by sine 36 degrees, but things will get complicated right there. And I think it's much better to use another trig ratio here. So we can use, let's just say you got tangent of 36 degrees, or we can use the tangent of 54 degrees. Let's try using 54 degrees, and then we can use the tangent of, let's say you got 54 degrees, and that's going to be equivalent to the opposites over the adjacent. So opposites of 54, you have y as a variable, and then as the adjacent, you got 8. And now basically you can multiply y on both sides, or 8 on both sides, to balance out the equation. These will cancel out, and by the way, this will be the exact answer of the side y. Like you get 8 times tangent of 54 degrees. But if you want to approximate it, you will have to use a calculator for this one. And if you multiply 8 by the tangent of 54 degrees, you get 11.01. So that's going to be side y right here. And that's how you solve a triangle with missing sides. In the next video, we'll discuss how to solve a right triangle in terms of finding missing angles as well. If you have two missing angles, then there's going to be a specific method we use to find those missing angles. And that's where we're going to talk about inverse trigonometric ratios as well. So thank you all very much for watching this video. If you guys enjoyed, leave a like, subscribe, and we'll see you guys in the next video. Bye.